Namaste students, myself Sunil Kumar from the Department of Computer Science. Today we are moving to the next session based on the chapter Input, Output and Memory Devices. So in the last session we discussed with the many things. In the last session we mainly discussed with the output device. Mainly output device mainly are of two types are there. One is soft copy device and one is a hard copy device. And last class we mainly discussed with the hard copy device printers. So if you take the printer mainly are of two types. There are mainly two types of printer available. One is impact printers, one more is non-impact printer. Impact printer means that will create an impact on the paper. Impact printer will create impact on the paper. That is impact printers. And also we discussed with the non-impact printer. Non-impact printer means that is not going to create any impact on the paper. So example for impact printer is dot matrix printer. Dot matrix printer and line printer are the example for impact printer. If you take the non-impact printer, one is inkjet. Inkjet printer is an example for non-impact, and thermal printers, laser printer. So these are the example, only some example for the impact printer and also the non-impact printers. So and also we discussed with the speaker. Speaker is one more output device that is used to get the output in the form of human understandable, means audio format. So these are the different input devices and output. Almost which one is necessary input device, which is a necessary output device, all we discussed. The next we are moving with the memory device, one more important topic that is actually known as memory device. What is a memory? If you take the memory means it is a storage part of computer. If you want to store the data in computer, either permanently or temporarily we can store. Either we can store the data permanently or we can store the temporarily in a system. So if you want to store the data in a computer, then memory is required. Memory is a storage part of the computer. If you want to store the data in a computer, either you can store the data permanently in a system or computer system, or we can store the data temporarily until the power on. We can store the data. So if you want to store the data like that, then memory is required. If you take the memory, if you are going to take the memory, we can calculate, we can measure the memories. We can measure the memory in the form of bits and bytes. By using bits and bytes, by using the bit and byte, we can measure the memories. Or memory units are there. If you want to take the memory, so you can say this is a big memory, a small memory. You can't say like that. It's not possible to say it's a big memory, small memory. In terms of bits and byte, we can say. In terms of bit and byte, we can say that which one is big and which one is small. So normally if you are going to take the memory, normally it is the smallest individual unit is bit. Bit means, one bit means you can store it, normally you can say one character can be stored. One character can be stored in one bit. So normally 8 bits equal to 1 byte. 1 byte means 8 bits. 8 bits that equal to the 1 byte. For example, you can say what is the 1? First number is 1. Next number is 10. 10 means what? 10 ones equal to 10. 10 ones. If you add, that will be 10. Then if it is 100, 10 into 10. 10 times 10 you have to add. That will be the 100. So if it is 1000 means 100 times you have to add. 100 times if you have to add. 110 times if you have to add, that will be the 1000. Right? Like that you can add. So like that memory also. 8 bits, normally smallest means bit, 1 bit. So 8 bit that combines, that is equal to 1 byte. 8 bits that combines, that will make 1 byte. So if you want to, 8 bit means we can store 8 characters. 8 bit means 8 characters we can store. Like that we can store the data. So normally you can say 1 byte. 1 byte means 8 bit. The next one is 1024 bytes. 1024 bytes if you combine together, or 2 raised to 10 bytes. 2 raised to 10 bytes if you combine together, that will make 1 kilobyte. Normally say KB. 1024 bytes if you combine together, that will create or that will make 1 kilobyte. So like that 1024 kilobytes. 1024 kilobyte if you combine it, that means 2 raised to 20 bytes. 2 raised to 20 bytes or 1024 kilobyte, that if you combine, that will create 1 MB, that means megabyte. That is actually the 1 megabyte. So like that 2 raised to 30 bytes, 2 raised to 30 bytes, that is equal to 1024 MB, megabyte. 1000 1024 MB, 1024 megabytes if you combine, that will create 1 gigabyte. Gigabyte, I will say gigabyte, 1 GB. 1 GB means 1024 MB. 1024 MB means 1 GB, gigabyte. Like that, 1024 gigabyte. 1024 gigabyte, that will create 1 terabyte. 1024 GB, that equal to 1 terabyte. Like that, 1024 TB, that is equal to the 1 petabyte. 1024 GB, you can see that table. 1024 TB, that will create 1 petabyte. So like that, 1024 petabyte. 1024 petabyte or PB, that equal to 1 exabyte. 1 exabyte, exabyte. Like that, 1024 EB means 1024 exabyte, that will create 1 zettabyte. 1 zettabyte. So 1024 zettabyte, that equal to 1 yottabyte. Like that, 1024 yottabyte, that will create 1 bronotobyte, and 1024 bronotobyte, that is equal to the 1 geobyte. Geobyte means it is 2 raised to 100 bytes. 2 raised to 100 byte means that is equal to 1 geobyte. So memory is like this: one is bytes, then kilobytes, then megabytes, then gigabytes or gigabyte, then terabyte, petabyte, exabyte, zettabyte, yottabyte, bronotobyte. Last one is the geobyte. These are the different measurement units. Normally we are using only with the TB. Just we reach with the terabyte we reach. So like that, again memories are there. Normally if we take any systems, we will use in TB. 1 TB, 2 TB hard disk we are using normally. So not only that one, more than that also. If we take the supercomputers are there, means number of bytes are going to increase, or a huge amount of data can be stored in that supercomputers. So in that cases we have to use the main things. But we are normally petabyte or in GB. Normally in GB, 500 GB or 1 TB or 2 TB hard disk, like that we are using now. So like that 1024 TB means that will create 1 petabyte, that we are not using till now. Normal computers we are not using, but if we take the supercomputers, we are using this one. These are the different measurement units of the memory. But if you take the memory can be mainly divided into 2 types. If you take the memory mainly we can divide into 2 types. One is primary memory, one more is secondary. This is the important part. Important part of this chapter is primary memory and secondary memory. If you take the memory device, the memory is mainly memory means what? Memory means the storage unit. The storage unit. If you want to store the data, storage part of the computer, that is actually not only the computer, wherever if you are going to store the data in soft copy, in the form of soft copy, that will be actually known as memories. So that memory is mainly divided into 2 types. That memory is mainly divided into 2 types. One is primary memory, one more is secondary memory. Memory is mainly divided into 2 types. One is primary, one more is secondary memory. If you take the primary memory, example for primary memory is RAM and ROM. Random access memory, I am going to explain later. Random access memory, and second one is read-only memory. First one is random access memory, second one is the read-only memory. These are the examples for primary memories. Then secondary memory example. Normally secondary memory, that is a permanent storage. If you want to store the data permanently, then we are making use of secondary storage devices. Secondary storage device example is hard disk. One next example is hard disk, CD, compact disk, DVD, digital versatile disk or digital video disk, then SD, secure disk, SD cards normally. SSD nowadays using. So SD cards. These are the some example, not all the example, some example for secondary storage. If you take a primary memory, 2 examples are there. One is the RAM, and one is ROM. RAM means random access memory. ROM means read only memory. Random access memory and read only memory. These are the 2 examples for the primary memories. So what is the primary memory? The primary memory is also known as main memory. Normally this is the main memory. Main memory means that the RAM is actually known as main memory. So totally we can say that primary memory is the main memory of the system. Primary memory is the main memory of the system. And what is the difference between the primary and secondary? It's a main question. What is the difference? You can't say it's a permanent or it's a temporary. One can't say that. You can say secondary storage is a permanent, but we can't say that primary is temporary memory. It's not possible. Because if you take the RAM is temporary in nature, but if you take the ROM, that's a permanent. That's a difference. We can't say that secondary storage, normally we'll say secondary storage is permanent in nature, primary is temporary. When power goes up, data will be erased. So it's not possible to say like that. Because if you take the primary memory, there are two memories are there, RAM and ROM, both also primary memories. If you take the RAM, that's okay. If you take the RAM, when power goes off, data what is stored in primary memory or in a RAM, that will be erased. If you switch off the RAM, the power supply is off. But if you are going for ROM, if you are going taking the device ROM, in that ROM device, data will be permanently stored. Data will be stored permanently in case of ROM devices. So we can't say that. But what is the main difference? The main difference is the primary memory is directly accessed by the CPU. So primary directly accessed by the CPU. CPU can access data directly from the primary storage. That is the main difference. If you are going to take the secondary storage device will access the data through the primary memory. Or if CPU access the secondary storage devices through the primary memory. Through the primary memory, we can access the secondary storage. It's the main difference between the primary storage and secondary storage. So we told CPU can access. Why CPU wants memory? Or why CPU wants data? If you see the first block diagram of the computer system, there are mainly four parts are there. One is input output is there. Input output, then CPU and memory. There are four parts: input, output, memory, and CPU. But if we discuss the input part, we discuss also in the output part. But CPU is there. CPU contains different units. One is ALU and CU, control unit and ALU. These are the two parts of CPU. Already we discussed about that one. ALU and CU. ALU means arithmetic and logic unit. CU means control unit. What is the work of arithmetic and logic unit or ALU? ALU will perform all the operations. All the operations are done inside the ALU. All arithmetic and logical operations are done inside the ALU, arithmetic and logic unit. The control unit will provide the control operations. Leave that. But if you want to perform any operation, I told, if you want to perform any operation inside the computer, where it's performed inside the ALU. ALU, where is the ALU? ALU is there inside the CPU. CPU means the processor. Inside the processor, all the operations are going to perform. If you want to perform the operations, actually data is required. So data should be present in the CPU. Then only it's possible to access, possible to perform the operations. It's possible to perform the operation when data is present inside the CPU. So data should be there in CPU. So when you are going to access the primary memories, CPU can directly access. CPU can directly access the primary memories. Primary memory can be directly accessed by the CPU. That's the main difference. And if you go for secondary storage, through the primary memory we can access the secondary. CPU cannot access the secondary storage. CPU cannot access the secondary storage directly. It's the main difference between the primary storage and secondary storage. And remember, through the primary memory, we are going to access the secondary memory. So secondary memory always gets too slow. Secondary memory is always getting slow because we are accessing the secondary storage device by using the primary storage. Through the primary storage, we are going to access the secondary storage. That's why it is getting slow. But if you take the primary memory, that is accessed directly by the CPU. It's the main difference between the primary and the secondary storage. So first we will move to the primary part. If you take the primary devices or primary memory, there are mainly two types of primary memories are available. Mainly two types of primary memories. We've got a different two types of primary memory. The first one is RAM, second is the ROM. ROM and RAM is the example for the primary memory. First we will see the ROM. It is known as roaming. There are different types of in ROM. What is the use of ROM? What is the use of ROM? The mainly ROM device is used to store the data permanently. Mainly it is used to store the data permanently. When you are going to switch off the computer, where data will be stored, data will be stored in secondary storage, normally hard disk. Normally in hard disk. When you switch off the computer, data will be stored in, or operating system should be there. Operating system is stored in secondary storage, or it's known as hard disk normally. Nowadays we are not using the hard disk, we are using the SSD technology or secure disk technology. Some memory chips are used. How we are using mobiles, same memory chips are used in systems. That is okay. But when you are going to use the ROM, when you use systems, normally data will be OS, operating system will be stored in your computer or hard disk. If operating system is not in the system, it is not possible to work with the system. So operating system is mainly stored in secondary storage, means hard disk. When you switch on the computer, the OS, operating system, is stored in secondary storage. That should be loaded to primary memory. Operating system is stored in secondary storage, right? So that should be loaded to the primary memory. Who will responsible for that? Who will responsible? That is actually known as BIOS, Basic Input Output System. That is actually known as BIOS. BIOS means Basic Input Output System. What's the work of BIOS? Work of BIOS is when you are going to switch on the computer, press the power button normally. We are not going to see any other things, just you will switch on the power button. When you are going to switch on the power button, operating system is stored in secondary storage. That should be loaded to the primary memory. At that time, that should be loaded to the primary memory. There, at that time, BIOS is the responsible person to load the data to the primary memory, to load the OS to the primary memory. It's our program. BIOS is our program. This BIOS program is stored in ROM. This BIOS program is stored in ROM chip. ROM is one chip. In that chip, these BIOS programs are stored. That is one operation. One more operation is there. When you are going to switch on the computer, now you can see all the devices. Once power will be blink, power is going to blink, then it is going to on. If you switch on the mobile, also same thing. You are going to switch on the mobile, also same thing. Once power will blink, then it is going to on. Means once power is supplied to all the devices, all the accessory devices. If you take the system, means if you are going to take the desktop, means monitor will be there, then speaker is there, then at the same time keyboard and mouse, all the different devices. Once power is supplied to all the devices. Why power is supplied? Then after that you are going to switch on. Why power is supplied means you will check the system. System itself will check whether all the components are working properly or not. System itself will check all the connected components are working properly or not. That is actually known as power on self test. Power on self test, that is a post. Power on self test, that is power on self test. When you are going to switch on the power, at that time system itself is going to check all the components are working properly or not. All the components are working properly or not. If some components not working, means it will produce the beep sounds. If some components are not working properly, means that system will produce a beep sound. So that is the system is checking itself. System is checking itself. When you are going to switch on the system next time, just see that. So this is the work of this one more program. One is a post program, one is BIOS program. Post program means power on self test. When you are going to switch on the computer, computer itself will check all the components are working properly or not. Computer itself will check all the components are working properly or not. That is post. And one more is BIOS, Basic Input Output System. Basic Input Output System mainly loads the operating system from secondary storage to primary storage. From the secondary storage to primary storage, operating system should be loaded. That's one program. That should be loaded. Then only you can work with the computer. Otherwise, it's not possible to work with the computer. So BIOS should be loaded. So these two programs are always required. These two programs always requires in a program, always require in a system. So these two programs mainly stored in ROM. These two programs mainly stored in ROM. So BIOS program and post program. Mainly two. There are other operations are there. I'm not going to explain the other operation, but This BIOS program, mainly BIOS program and post operation, both operations are stored in ROM chip. Understood why ROM is required? ROM is using these two main programs, basic programs. So that is stored in ROM. So if you switch off the system also, that program should be there in that. That should be there in the system. So that's why ROM is used. So readme, that is a usage of ROM. That's why ROM is required. So ROM, if you take the ROM means it's a read-only memory. We can read. It is not possible to write. Normally, ROM means it is only possible to read the data from the memory. It's not possible to write the data. That is actually the ROM, read-only memory. If you take the ROM, there are different types of them. One is ROM. Second one is PROM. P-R-O-M. PROM. Next, EEPROM. Next one is EEPROM. E-P-R-O-M. Last one is EEPROM. EEPROM is E-E-P-R-O-M. So these are the mainly four types of ROM devices. The first one is read-only memory. One is read-only. ROM means read-only memory. Next one is PROM. PROM means programmable read-only memory. Programmable read-only memory. Next one is EEPROM. Erasable programmable read-only memory. Erasable programmable. Erasable PROM. Erasable PROM means erasable programmable read-only memory. Last one is EEPROM. EEPROM means electrically erasable programmable read-only memory. So first one is ROM, read-only memory. Second one is PROM, programmable read-only memory. Programmable read-only memory. Programmable read-only memory. Next, EEPROM, erasable programmable read-only memory. Erasable programmable read-only memory. Last one is EEPROM, electrically erasable programmable read-only memory. Electrically erasable programmable read-only memory. Now what is the difference between these four types? First we will go for programmable. So, ROM means data will be stored, not possible to change. But first one is programmable read-only. First case, programmable read-only memory. In case of programmable read-only memory, once we can write the data, or we can say when they are going to produce the chip. When you are going to produce a chip, when you are going to manufacture the chip, when companies are going to manufacture the ROM device, at that time they will write the data. At that time they will feed the data. They will program the data. Programming means program the data. Writing the data is known as programming the data. Writing the data into a ROM chip is known as programming. So they will program the data into the ROM chip. That is a programmable. After that is not possible to delete. After that is not possible to delete. Example, we can say. Example, if you are buying empty CD from market. Empty CD will buy from the market. Once we can write the data, once we can burn the data. After that is not possible to delete. After that is a read only. It is not possible to delete. It is not possible to delete. So virus is not attacked. There are some other reasons are there, but it is not possible to edit once again. It is not possible to write the data once again. That is a empty CD if you buy from market and write the data. That is the example for ROM. Actually, that is not a correct example. The correct example is, the correct format is when they are going to manufacture the ROM device, at that time they will program or they will write the data. That is actually the programmable read-only memory. The next one is EEPROM. As the name indicates, it is erasable. Erasable programmable read-only memory. We can erase the data and same time we can write the data anytime, like a USB device. Like a USB device, we can write the data and we are deleting the data. But if you want to write the data or if you want to erase the data, not system, we are using a special PROM programmer. We are using the special PROM programmers are required. Special PROM or ROM programmers are required. PROM programmers. Programmable device is required. By using a particular device, PROM programmers are required. That programmer device we are using to write the data and also possible to delete the data. To erase the data and also possible to write the data. If you are going to write the data or if you are going to erase the data, mainly we are making use of UV rays. Ultraviolet rays are used. In case of here, UV rays are used. Ultraviolet rays. Ultraviolet rays are used to write the data to EEPROM and also possible to delete the data from EEPROM by using the ultraviolet rays. The next last type is electrically erasable programmable read-only memory. This is also same as EEPROM. This is also same as EEPROM. It is electrical, as the name indicates here. Electrically erasable programmable read-only memory. Electrically erasable programmable read-only memory. In case of both also same EEPROM and EEPROM, it is possible to write, possible to erase, possible to program, and same time possible to erase. But in case of EEPROM, normally we are using with the ultraviolet rays. Normally we use the ultraviolet rays in case of EEPROM, but in case of electrical erasable, last case we are using electrical signals. Electrical signals are used to erase the data, and electrical signals are used to write the data. Write means programming. Possible to program and also possible to erase. These are the different types of ROM device. One is ROM, read-only memory. Second one is PROM, programmable read-only memory. Next one is EEPROM, erasable programmable read-only memory. Next one is EEPROM, electrically erasable programmable read-only memory. So these are the mainly 4 types of ROM device. So next we will move to the RAM, random access memory. Last time here is a random access memory. Random access memory means that is actually it is random access memory. It is known as the main memory of the computer system. Random access memory it is known as the main memory of the computer system. If you take the computer system, this one is main memory. Random access memory. So if in case of RAM, when power is off, data stored in RAM will be erased. So in case of ROM, data will be permanent, but in case of RAM device, when power is off, at that time, data what is stored in RAM device will get erased. Data will be erased in the RAM device. When you are going to use the RAM, normally RAM is not there, system is not going to work. So whenever in case of RAM, when you are going to switch off the system, at that time, which data you stored in RAM device, that will get erased. Until power on, data will be there. When power off, data will be erased. This is made up of chips. Some chips are used. Semiconductor devices are used. By using the semiconductor device, this chip is made with the RAM. So if you take the RAM, there are many different types of them. There are different types. One is SRAM. Second is DRAM. Next one is SDRAM. And last one is DDR. One is SRAM. SRAM means static RAM. DRAM means dynamic RAM. Then SDRAM means is not a static dynamic. It is synchronous dynamic RAM. Synchronous dynamic RAM. Last one is DDR. It is a double data rate. You can see that one. Double data rate random access memory. These are the different types of RAM devices. One is RAM, SRAM, DRAM, SDRAM, and also DDR, double data rate random access memory. So these are the different types of RAM devices. Here, the first one is RAM, random access memory. The first one is SRAM. It is known as static RAM. In case of static RAM, it do not have the refresh time. So if you want to store the data, data will be stored in a sequence. Data will be stored in the form of sequence. So first, if you want to store the letter A will be stored here. After that, if you want to store next letter, that should be stored in next position. If you want to store the next position, the system should be refreshed inside. System or memory should be refreshed. When memory is refreshed means next data will be stored here. When memory is not going to refresh means the data will be overwritten here. A is there, upon that B will be stored. Right. This is a data storage mechanism. I am not going to explain detail. This is a simple mechanism. So if you want to extract data, first A will be stored. If you are not refreshing means once again B is going to be stored in same position. So here A next should be stored in next position. So if you want to store the data in next position, we are mainly making use of, we have to refresh the system. We have to refresh. That refresh is manually should be done in case of static RAM. In case of SRAM, that refresh should be done manually. Refresh mainly should be done manually. If you take the DRAM or dynamic RAM, that will based on some time intervals. We will set the some time interval based on that system is going to refresh, or that RAM is going to refresh, so data will be automatically stored. But here is SRAM, we have to set the time. The next one is SDRAM, synchronous dynamic RAM. Synchronous dynamic RAM will take the refresh by using the system clock. If you take the system will generate the clock signals. Normally, I am going to explain what is the clock signal. There is one more topic. So, system is going to generate the clock signals. That clock signals are taken by the RAM device and is going to refresh. That is going to refresh. When each time system is going to produce signal. Each time the system is going to produce signal, that signals are taken from in SDRAM and it is going to refresh. That is a synchronous dynamic RAM. And last one is DDR. DDR means double data rate. So it is a double, is a name indicates, is a data writing speed and data fetching speed is double of SDRAM. Data writing speed and data fetching speed is double of SDRAM, or it is known as synchronous dynamic RAM. Double data rate RAM. The speed is double of SDRAM. Nowadays we are using DDR1, DDR2, DDR3 like that. DDR4 also we are using nowadays. So these are the different types of RAM device. One is RAM, SRAM, DRAM, SDRAM, and last one is DDR RAM. By here we reach the end of session today. In this session we mainly discussed about memory devices. The first one is memory measurement units. Here are the different memory measurement units. One is from bits to gigabyte. Bit, byte, kilobyte, megabyte, gigabyte, terabyte, petabyte, exabyte, zettabyte. Then after that yottabyte, notabyte and gigabyte. These are the different memory units. After that, the types of memory. Types of memory meaning there are two types, as a primary memory and also the secondary memory. The primary memory example is RAM and ROM. Secondary memory example is hard disk, CD, DVD, SD card, like that. Different examples are there. Then also we discuss what is the difference between the primary memory and also the secondary memory. Primary memory is directly accessed by the CPU. Secondary memory is accessed through the primary memory. And also last we discussed the two types of RAM and types of ROM. We discussed with types of ROM. ROM, PROM, EEPROM, EEPROM. These are the main four types of ROM. And also we discussed with the different types of RAM, random access memory. But here I will wind up my today's session. Thank you.